information, Carol has prepared this slide so you can have a look at the general changing some information about dinner tonight, where to go, etc. So I don't know if you have time to have a look at that, but otherwise you can still look at the slides on the TERENA website, www.terena.nl, TNC2004. Anyway, it's just about the general things that you might know. But I have another important thing to say that is about the speakers in these sessions. Initially, there should have been, let's say, 4 presentations, 2 made by the same speakers and other 2 made by 2 different speakers. But one of the speakers is sick, so he couldn't make it. In the meanwhile, I've asked David Chadwick to give an overview about his project. David told me that he was very happy to provide the overview, but I can't see David around, so we have quite a problem with this. But okay, let's start with the first presentation that is that will be given by Michael Linden from FUNET. He's the coordinator of authentication and authorization projects in the Finnish higher education. The first talk will be about the use of city cards that are PKI based, and they are used for payment in the campus. So Michael will refer about their experience on this. Do you want to? Try to retrieve your presentation.
Okay, hello everyone. My name is Mikael Linden. I'm from CSC, the Finnish IT Center for Science, and indeed I have 2 presentations here. The first one is something that has been done in Tampere Polytechnic, and this speak is about authentication and also about cooperation between a higher education institution and the city of Tampere. It's about city card and use of city card on the campus. Tampere Polytechnic, it's a medium-sized polytechnic in Finland. Well, polytechnics, Fachhochschule auf Deutsch, those belong to higher education in Finland, but they are not universities. Actually, they are 30 polytechnics in Finland, and Tampere Polytechnic is one of them with 5,000 students and about 600 staff members. Legally, Tampere Polytechnic belongs to the city of Tampere. In Finland, polytechnics are funded by the state, so the relationship of the city of Tampere and the Polytechnic, it's not so, there's not so strong binding as it appears. About the IT infrastructure in Tampere Polytechnic, there's the organizational unit called Computer Center that maintains the IT infrastructure, and user administration is one part of that. The task lists of the Computer Center, and in practice the user administration is done using LDAP directory, it's Sun1 directory, and users have one username and password for most of the services in the Polytechnic. And there's a link between the LDAP directory and the student registry, so that accounts are created and closed automatically based on the changes in the student registry. So that's what I have been calling central user administration. About using smart cards and PKI in strong authentication in Tampere Polytechnic. Well, Tampere Polytechnic was willing to start using strong authentication based on tokens and smart cards and certificates. But on the other hand, Tampere Polytechnic didn't want to bring just new smart card to the wallets of people. The idea was that Tampere Polytechnic tries to decrease the number of smart cards that people have and integrate new functionalities, new applications to existing smart cards. About concrete infrastructure changes in Tampere Polytechnic's 800 smart card readers were installed to workstations in the computer classes and in the staff desktop computers. So more than half of the workstations used by students were made smart card enabled. And then some changes were made to the LDAP directory. So basically the attribute user certificate was populated by the certificate in smart card. Okay, then a few words about cooperation between the Polytechnic and the city of Tampere. City of Tampere has a 5-year lasting program called eTampere, and it's a large collaboration project of research and education, so it means universities and polytechnics in Tampere and also commercial business players and then the city of Tampere. And one small part of that large project was this eTampere card, and the pilot that started last year and it goes on still to the end of this year. And the idea was that the city of Tampere provided 5,000 smart cards to local residents, and most of them, 3,500 of the cards were given to local students in Tampere Polytechnic. And the idea was that because students are quite computer skilled people and they have good faculties at home and in the school, and there are also a lot of services that students use, then it makes sense to give those pilot cards to students. And the outcome was that the penetration of smart cards among the active students in Tampere Polytechnic reached 80%, and it's quite a lot of smart cards in that population. And the basic idea in that pilot was that let's bring together the public and private sector organizations to provide services on a single card. What were the services available for cardholders in that pilot? Well, there were services provided by 4 organizations. At first, the city of Tampere. The smart card could be used for public transportation. It means buses, local buses in Tampere, and also in swimming halls that belong to the city of Tampere. So it can be used for payments there. And also electronic services, basically something that's on the web and that requires authentication, user authentication. There are not so many services actually provided by the city to the citizens on the web. But in Tampere Polytechnic there are more services. At this point in the pilot, the smart card was used for workstation logon, so it was simple Windows 2000 logon using the smart card instead of password. And another service was signing digitally and also circulating an application for over time. In Finnish polytechnics, the students have quite rigid rules that they have to graduate in 4 years, and if they are not able to do it, then they have to ask for permission from the school letter, and in the old system they signed a paper with a pen, and in the new system the signature was made digitally using the smart card and a certificate and a private key. Third category of services was again payments. It was the payment for the student lunch in the local student restaurant in Tampere Polytechnic. In Finland, in Finnish higher education, the restaurants in polytechnics are privately operated and owned, and this was another privately owned restaurant, and students were very interested in using the smart card for paying the lunch, because the smart card is contactless and it makes the payment very fast. You don't have to pick up any coins from your wallet. You need to just show the smart card to the smart card reader. And then the student union of Tampere Polytechnic had also voting in the election made electronically in the student union's council. So these were the services provided in the pilot. Some of them are related to payments and some of them related to strong authentication. About the technology of the card. The card was a hybrid card. It means that actually there are two chips in the card. The one which is contactless, the standard it used was called MyFair, and the contactless chip was used for electronic payments. It had an electronic purse inside of it, and it can be used in buses and swimming hall and a restaurant. And the other chip was a chip with contacts, and it had the personal certificates and related private keys inside. ISO 7816 and PKCS 15 were the standards used. About the PKI, there were two separate certificates in the smart card, one for authentication and the other for non-repudiation, means in practice signing those documents like that overtime application. And the CA was a commercial player, Sonera. Today its name is Telia Sonera, a Finnish-Swedish teleoperator that has CA of its own, and those certificates were signed by Sonera. The registration authority was the local bank in Tampere. Its name was Osuuspankki, and that actually delivered the smart cards to the people, the students and other people, because giving cards to people is something that banks are very familiar with, and they know how to do it. About the unique identifier of the user in the certificate, the unique identifier was called Eetu, and it's a unique number assigned by the city of Tampere. For Windows 2000 logon, an extra certificate was added to the card. It was because, according to Windows 2000, there have to be the principal name of the user inside of the certificate. So the certificates signed by Sonera were not applicable in the Windows 2000 logon in Tampere Polytechnic. So the CA for that certificate was the Computer Center of Tampere Polytechnic, and the idea was that the extra certificate binds the username to the public key in the smart card. During that pilot, a survey was made for the users. It was made 1 or 2 months after the cards were distributed to the users, and the users were asked that what are the important properties of that card. And you can see that strong authentication is something that users don't feel very important. So things like paying car parking fees, using the card as a library card, as a passage card in a school, to pay lunch, pay in the shops, to buy tickets for concerts and ice hockey in the city of Tampere, or use the card for voting. It's much more interesting for the end users. So increased security is something that is not the way to sell the idea of PKI smart cards to people. Only telephone card was something that was considered even less important, maybe because everyone has a mobile phone, so having telephone cards isn't very important today. Okay, from pilot to production, what are the experiences and challenges? For the city of Tampere, maybe the biggest problem is that those certificates are quite expensive. And on the other hand, there are not so many services, at least services provided by the city of Tampere, that utilize those certificates. So it's not easy to find a business model. Someone have to pay those certificates, and to find the business model for them, it's quite difficult. So it's not clear if the production after the pilot, if there are any certificates in those production cards. As the previous slide showed, libraries are services that are considered interesting for end users, and the next challenge for the city of Tampere is to integrate the card to the library system so that it can be used as a loaning library card, same card, so that you can use it for loaning and also for those small payments in the city libraries. And also one challenge is to replace the hybrid card with dual interface card. So dual interface card has only one chip, and the single chip can be accessed either contactless or by the contacts, so that you can, for example, load some money to the e-purse using the contacts. At the moment, you can load new money only by the contactless interface. For Tampere Polytechnic, the problems were mostly non-technical, like providing support in the help desk, and like how to organize loading the extra certificates for Windows 2000 logon. They didn't have any significant technical problems in Tampere Polytechnic, but at the moment the certificates are used just for Windows 2000 logon, and it's still too narrow. There should be more services for strong authentication like web authentication, SSH connections, VPN, and so on. I think that was my last slide. Any questions?
Given that use of certificates for web authentication is pretty common, is it just a matter that applications haven't been modified to do that yet? Shouldn't be any technical problems with that, I think.
I think the way to bring strong authentication for web applications could be use some campus single sign-on system like PubCookie and so on. They have had discussions, but well, in Tampere Polytechnic they don't use Apache web servers, so it makes the choice of the web single sign-on system more difficult.
So they don't use Apache?
At the moment they don't use.
Do you have any information about how the financing of all the card readers, especially for the university, is put in place?
Okay, those 800 card readers were paid by the institution itself. In that.
Motivated by?
Pardon?
Yeah, but how were they motivated by for that?
Well, the smart cards were paid by the city of Tampere. So those 3,500 smart cards were paid by the city, and it was the deal that the city pays the smart cards and the institution pays the smart card readers. And that was the deal, basically.
They're not card readers distributed at homes?
No, in that pilot.
Any plans? You won't get any critical mass if there's only specified places where you can do it.
Yeah, you're right. I think if the students have money to pay for computers at home, maybe they can also buy the smart card reader. I think that was the logic, because in Tampere Polytechnic 800 smart card readers for those workstations on campus, it's quite expensive already. So getting smart card readers at home is something that the users have to pay.
And this pilot will run until next year, and then will be full evaluation, or will it be stopped somewhere in between? Or?
Yeah, the pilot lasts until the end of this year, and I think some conclusions will be done during the autumn, I think. But personally, as I have been following the pilot, I think the problem is that those PKI is so expensive that maybe it's dropped off from the card before production. At least personally, I'm afraid of that. Yep. Pardon? The cost of the PKI smart card was about, I think, 50 euros. It included the card and the certificate and the PKI behind it. Yep, revocation was also included. Perhaps that was a signal that my time is over.
I've said to switch off the mobile phone, but they didn't listen. Yeah, I should, but he's one of the speakers, so I should do it later.
Okay. Any other questions? Yep.
How much certificates have Tampere expedited? I mean, you are speaking here about the students, but how many certificates has the city of Tampere expedited?
In that pilot, it was 5,000 certificates and 3,500 were given to Tampere Polytechnic students. And actually it was the number of the cards and 2 certificates in each card. Okay, still one question. No. Well, thank you.
Okay, now switch off your mobile phone immediately. Okay, the second speaker is Wolfgang Schneider, and he is the head of the department called Security as Market Technology at the Fraunhofer Institute, which I've just found out that is a very big institution distributed in all Germany, whereas I thought it was located only in Berlin somehow. And he will talk about a project that is currently running in Germany, and he will present about a client-server model-based PKI. So I'm putting on, yeah. Oh, sorry, no slides. Cool. Yeah, here we are.
Thank you very much. Can we have a full-size presentation of that? I don't know. Where is that in Adobe? Full screen, yeah. Okay. I'm presenting here a project which I presented already 2 years ago in Ireland, I believe, at the TERENA conference when the project started. So I just told about the goals of the project. Now the project finished by the end of last year, and I will just outline what the accomplishments of that project were. The background or the motivation of that problem of that project was that PKI are not fully utilized today. Deployment of PKIs is very much behind all expectations which we had a couple of years ago. PKIs are even not used in major enterprises where it would be much easier than in a public environment. And the reason for this is mainly that all problems coming along with PKI are really very complex, much more complex than we anticipated in advance, which makes the integration of these services into any sort of application, which makes it very expensive, very problematic. We had a number of major field tests of using PKIs in major German companies, for instance, like Volkswagen, like Deutsche Bank, and companies of that size. They spent millions of euros in order to try to integrate PKI into their IT systems, which they are using enterprise-wide. And basically, most of them failed, and PKIs are used only in very small, very isolated environments. So PKIs tend to be disjoint by now. There's one cannot speak of a global PKI or a global connectivity, cryptographic connectivity between people worldwide. It's just not the case. So that was the background of that project, and the idea was that we have to remove all sort of complexity which comes along with the use of digital signatures and certificates, PKIs, revocation of PKIs, and all that kind of stuff, problems. We have to remove that from the end-user system, because the largest problem next to the difficulty to integrate these things into the existing applications was the deployment problem of that. So if you deploy, for instance, an email system which includes the use of secure email with S-MIME or something like that, if you deploy that to hundred thousands of employees of your large company, and you have a change in a parameter in that environment, say a root, a trust anchor changes or something like that, you have to redistribute that to all the people, which is an enormous cost factor, and it's just not feasible to do that. So the conclusion was that on the end user side, on the client side, where your application resides, on your laptop, on your PC, or whatever you have, security has to be parameter free, more or less. There should be no need to reconfigure anything over the time. It has to be something like a web browser. You use the same web browser on your system, no matter in which internet environment you currently are. There's no need to reconfigure anything if the internet reconfigures at some place. And the idea was that with security, it has to be similar. So the idea was to develop some sort of client-server-based PKI, where all PKI-relevant complexity and all PKI-relevant procedures move from the client side to a server side. I have to add, not on the generation side. So if you generate a digital signature to authenticate towards someone or to sign something, this has to be done with the help of a smart card or something like that. The problem we faced was mainly on the validation side. So if you have not just a tree topology of your PKI, if you have some sort of meshed networks and multiple trust anchors and things like that, then the validation process, the validation of a digital signature is a pretty complex task, and the idea was to put that all on a server which can easily be administered centrally and which makes life for the normal end user much easier. So signature validation, trust path construction, all stuff regarding revocation of certificates, so the use of CRLs or the use of OCSP or whatever you have, and the management of security policies, all during validation, all that has to be removed from the client side. The aim was to gain by that a simple access to any sort of PKI topology, because the PKI topology can be administered by a system admin or something like that in that environment. The advantages for the clients are pretty obvious. They don't have to take care about anything with regard to security. That's what we all want to have. We want to work in a secure fashion, but we don't want to know exactly what we have to do in order to reach that. We don't need to support multiple protocols in your client, in your desktop or laptop computer. It doesn't need to be configured in any way. So the integration aspect on the application side would be largely removed, or the integration difficulty would be largely removed by that kind of approach. The disadvantage on the other side is also that we have to go away from the notion of the end-to-end security in some way. End-to-end security meant in the sense of all the people who promoted digital signature legislation and all that kind of stuff, that a person can be made responsible for their digital acting on the network. And if we delegate parts of the complexity to a server, a centrally administered server, this notion goes away slightly. But this notion of end-to-end security, this turned out in the recent years, I think, is not all that important. Not that important as we all thought a couple of years ago. It's very important to see that such a kind of PKI server is distinct from a CA, from a certification authority. It has nothing to do with the certification authority. You need the certification authority only once, when it creates your keys and your certificates and so on. Otherwise, the certification authority is out of the game. You don't need it anymore. The PKI server is useful during the daily business when you are using your certificates and your keys and your signatures and all that kind of stuff. The trust model, the underlying trust model, very much simplifies because the end user has only just one trust anchor in the end, and that is the certificate of that PKI server. So imagine a large company, a large enterprise, which provides such kind of PKI servers. The employees of the enterprise only need to trust that PKI server. They don't have to know anything about other trust anchors, against incoming certificates can be verified and things like that. So what we have in mind with that project is that we have a PKI server in the middle of the system where all the applications, be they on the desktop, on your mobile phone, on your PDA, on your laptop or wherever, where they are able to access that PKI server with a very simple query protocol, which does not need to know anything about security. It's just a very simple protocol, a question and answer protocol saying, I have this here, is that okay, yes or no? And the PKI server basically says yes or no. And the application can either trust or not trust in that case. And the PKI server itself, he connects to other PKI servers, he connects to repositories, he connects to OCSP services, to LDAP services, and whatever you can imagine. A point or a problem area which we fairly thoroughly elaborated is that of policies. Security policies is something which many people consider as to be very academic and not of practical relevance. I'm not sure whether this is true or not. Maybe they are overestimated in some places, but I think it certainly makes sense to distinguish between different policies which reflect to different uses of keys and certificates in different application contexts. And the central management in the PKI server allows central management of policies and allows to make that, to hide that from the end user and make it a very powerful tool to manage policies. And basically we provided two options for defining policies. One are so-called persistent server-defined policies, which are there for the lifetime of an application or for the lifetime of certificates and so on. And the second sort of policies is some which can be temporarily defined by a policy definition protocol online by the end user. And the policies are applied in the validation process. When an end user asks, I have that signature here, or I have that certificate, or I have that S-MIME format here, please tell me, is that okay or not? Then the PKI server applies these policies, which are either managed by the IT manager or managed by the end user through the policy definition protocol. And we support two types of policies in a moment. The first type is validation policies, which we are using for path validation, which can be very complex if you have a complex topology. And a second type of signature policies, which are used for the validation of digital signatures, which you might have on a document. Policy contents might be that you support a set of trust anchors, maybe not just one. Part of the policies could be that you define constraints. Name constraints, for instance, is a very powerful means. Path length constraints, permitted algorithms, and things like that. minimum key sizes, and so on. You might define revocation check requirements. You might require to check revocation lists or not. You might require the check of OCSP services online and things like that. And you might define signature policies which, again, might contain constraints for permitted algorithms and references to validation policies, for instance. What we implemented on the PKI server are a set of policies. For instance, that policy definition protocol, which I mentioned already, we implemented a policy retrieval protocol. We implemented path construction, path validation policies, signature validation protocols, certificate discovery protocols for the case you use a PKI for the encryption case, where you need to retrieve for public keys of possible recipients. So all these protocols are part of the PKI server. A part of these protocols we developed on our own. A part of these are under discussion in the moment in the IETF, where it might be where it might make sense to make a change to SCVP protocols or whatever will emerge from the IETF process. So since we started with that project before the IETF process started, we have a set of protocols which we defined on our own, but after what I saw from the IETF process, most of the functionality of that, what we implemented here, can be made by using SCVP or similar protocols. However, the protocol issue, what was not the most important in our project, that can be a point of a later adaptation of the then standard protocols coming out of the IETF. We have one major application of that PKI server in the moment. We are cooperating with a major Japanese company, technology company, which provides Japanese telcos with technology. And we are using that PKI server in the mobile environment, where you have the problem of roaming different networks. For instance, in the hotspot environment, if you have different hotspots, wireless LAN hotspots, you might operate them all over the world, and you might accept users from various networks in the world. You have a roaming problem, because on the hotspot you might not only accept users when they issue their credit card information, you also might accept users on the basis of contracts with the users have with their home provider. So the increasing use of hotspots creates an increasing roaming problem in that area. And we have requirements on the authentication process in that point, which is not only that the end user has to be authenticated by the network in order to make sure that he pays the bill, but also that the network has to be authenticated by the end user in order to make sure that he has a trustworthy network. This is very important. So that mutual authentication is increasingly becoming important in that area. And the problem is really that if you have an increasing number of different providers worldwide, that the providers don't have the trust anchors of the user, and the user does not have the trust anchors of the providers. And one problem which is very obvious, the end user has no network when he tries to go into a hotspot network, which would allow him to verify a signature. So the end user has to trust in some way the network he connects to about its identity. That's a real security problem, and we are using that in that we supply two different types of PKI servers. We have a so-called home provider of the user. We have a visited provider when he's on travel with his laptop and he tries to connect to a hotspot or to a wireless LAN. And accordingly, we have a PKI server of the home provider. We have a PKI server of the visited provider. And the obviously, we are using the PPP protocol for certificate-based authentication, and the end user, the user gets a connection to the PKI server of his home provider here in order to get the provider network authenticated, and the visited network gets a connection to from his PKI server in order to authenticate the end user. In that context, that kind of PKI server is a very useful thing to have, and that's what we are testing in the moment in a major environment in Japan. Unfortunately, I'm not allowed to tell you the name of the company. I asked in advance, but the Japanese companies are very restrictive on that. I don't know why. Okay, that was my short presentation about that.
Can I ask a question?
Yeah.
About when he's logged into the visited network,
Yeah.
then how does he know that it's definitely the provider that it's meant to be? Because the root of trust is held back in his home PKI server, but he's attached to the visiting provider's PKI server. So
the end user, goes into the network of the visited provider, and he gives some sort of identity to that network. So the visited network can choose the home network by using that identity, not on an authenticated basis, but on a name basis.
okay, like where is you from or something?
Yeah, and so the visited provider makes a connection to the home provider and asks the PKI server of the home provider to authenticate his identification. So the PKI server, the PKI server of the home provider, in the end authenticates the identity of the visited provider, and the end user is able to verify that because he trusts the key of his home provider.
So and that also authenticates the user.
And it works the same way the other way around. Yeah.
Why is it important that you trust the visited provider? Why not let that happen in the back end? I mean, I don't really care if I can trust that provider as long as I get connected. I want to have a secure connection with my home provider, and that's all.
That's true in most cases, or in many cases. Users don't care about that. But imagine a situation that you transport, for instance, company information over that kind of connection. Then a company policy might require that you are using only networks which you can trust. And this is a way to provide that kind of trust.
Yeah, but that way you mix two things that I'm not so sure you should mix. What we tend to say at SurfNet in any case is you have access to the network and then you have the ongoing transport. Why not do with this system, EFTLS or whatever EF type you want to use, the authentication for the network? If you then need secure communication, use a VPN or whatever you feel like.
Yeah, that's certainly an alternative for that, using a VPN. So if you don't have a VPN which goes end-to-end to your company, for instance, but if you use the VPN facilities of the visited provider, for instance, you have to trust him. Yeah? So that might be an alternative. There are certainly other alternatives how you can get a trusted connection as well. So it is not absolutely necessary that you have some sort of trusted provider on your hotspot, for instance. But if you don't have other means, that could be a valuable alternative, I think.
Do you propose an extension to the TLS protocol or to the EFTLS protocol?
We are proposing an extension to the TLS protocol, which would allow to make that necessary authentication. So there's an extension which we propose. I don't have a slide, I believe. Is that the last slide? We propose to make that authentication exchange in early phase of the protocol in order to make it possible that what we are doing here is an authentication for someone else. So it's not an authentication for yourself. The home provider or the PKI server of the home provider authenticates the visited provider and vice versa. And that kind of exchange is not part of the protocol. It would be a very, very simple, small extension to do that.
How do you do the authentication between the client and server?
How do I go back here? Yes, what was the...
Well, you have a PKI client server solution. How do you say the authentication between the client and the PKI server?
The authentication between the client and the PKI server can be done, for instance, with the SSL or with TLS connections. So what you need in the end is that on the client side, you have one trusted key or one trusted certificate. That's the public key of the PKI server. And once you have that, so you have to install that on your client. And once you have that, you can have a trusted connection, a trusted transport connection between the PKI server and the client.
I think we have to stop the questions because there are other two presentations. So, I mean, you can discuss offline. Sorry for this.
Okay, thank you very much.
Thank you. Okay, okay, again there is Michael Linden, and this presentation is, I mean, it's quite interesting in the sense that it presents a variation of the common scenarios that allows users to connect to a WLAN using a web interface and to, let's say, to transmit these credentials of the user to a radio server. The radio server has been replaced with a shibboleth system, and Michael will tell us about this. Thank you.
Hi again. Now I'm a spokesman for another Finnish higher education institution, namely the University of Helsinki. And Viljo Viitanen is the guy that has actually done the dirty work in this experiment. The title is about WLAN roaming experiences, and maybe the title promises too much. At the moment we have demonstrated that system, but it has not been used with real users in real environment. About background of authentication and authorization issues in TERENA, there are two task forces, the mobility task force and the ACE task force. Mobility is for network level authentication and authorization, and TFACE is for application level access. In the mobility group, they have presented 4 different solutions for network-level roaming access. 802.1x with radius hierarchy and VPN with complete list of VPN gateways, web-based redirection with radius hierarchy, and roam node with radius hierarchy. And in the phase there are several different architectures for AAI, authentication and authorization infrastructure. Shibboleth, the one made by the Americans, and PAPI from Spain, FEIDE from Norway, A-Select from the Netherlands. And in GN2 project, these issues will be brought together in TERENA group. Some background about the University of Helsinki and why they came to this solution. The University of Helsinki is the largest university in Finland with almost 40,000 students. And the campus is in the city heart of Helsinki. And that's the point why University of Helsinki is deliberate to join the WLAN roaming as such. Today in Finland there are about 10 institutions using the WLAN roaming that is based in this web-based redirection and radius hierarchy. But University of Helsinki has found that it's a problem for them because they are in the city heart of Helsinki, and probably there would be much more visitors coming in than going out, and it would not be fair for University of Helsinki because the costs could accumulate for the university. But in University of Helsinki, they could allow roaming access for some smaller subgroup, like staff in other universities. And then they won't perhaps provide roaming access for students in other universities, but for some smaller group like staff. So what they need is role-based authorization. And for role-based authorization, they need information about the role of the user. So the role attributes need to be passed from the user's home institution to the University of Helsinki, and that's something that AI technologies like Shibboleth are made for. That's the architecture. Here we have Bob. He is a lecturer in University of Tampere. Here we have University of Helsinki, and here is University of Tampere, and here is the Wave server, where are you from server in Shibboleth terminology. It means the place where the user selects his home organization. This is the access control device that Viljo has Shibbolized. It's in Shibboleth terms, it is a Shibboleth target and Shibboleth origin for Bob. The Shibboleth origin is here in the University of Tampere. Bob opens his WLAN laptop and accesses the docking network, and he opens the web browser and he gets HTTP redirect from this access control device and the Shibboleth part of it, and he is redirected to this Wave server. And in the Wave server, Bob selects his home organization from a drop-down list, and he selects University of Tampere, and then he is redirected to the Shibboleth origin in the University of Tampere. And the Shibboleth origin authenticates Bob using his username and password, and then the Shibboleth attribute exchange takes place between this Shibboleth origin and the access control device that is the Shibboleth target in this architecture. And as a result, this access control device becomes aware of Bob's role, that Bob is a staff member in University of Tampere, and then the access control decision can be made based on that role. And what's worth noting is that in this access control device there have to be list of all the shibboleth origins in that federation, and also the name and IP address of the wave server, so that unauthenticated traffic in SSL port 443 is allowed through this access control device before authentication takes place. About benefits, this makes role-based authorization easy, because visiting institution can make access control decision based on the roles provided on shibboleth. It also preserves privacy, because the identity of the user need not to be revealed to the visiting institution. Shibboleth passes only the user's role and the home institution, but the user's identity is not revealed. And it also provides better security than the plain web redirection and radius model, because the username and password is passed to the home organization and the shibboleth origin in end-to-end SSL tunnel. So it means that the user's password is not visible for the visiting institution. And this also brings together the network and application level architectures, so there's no need for overlapping architecture. About disadvantages, radius is very widely used protocol and technology and supported by a lot of products. This AAI technology and, for example, shibboleth is something that's still coming, so it's not so mature as this radius. In Europe, I think Switzerland and UK and we in Finland are now started using shibboleth. And another disadvantage is that there have to be the list of those shibboleth origins in that access control device. About practical experiences, HubNet, that's the local public access network in the University of Helsinki. It has been available since 2001, and Viljo is actually the guy that has implemented that HubNet. And it's for wireless LAN and for wired access in the University of Helsinki. And the access control device is a Linux box with Apache web server and a web end user UI, so that the users can give the username and password for it. And what Viljo has done is that he has now shibbolized that access control device and replaced the radius-based hierarchy with shibboleth. At the moment, this HubNet is available only for students and staff in the University of Helsinki, so it's not connected to the roaming infrastructure in Finland. And the plan is that the piloting with other universities will start already before autumn. Viljo has some plans to start it already in June, so in this month. And the implementation will be publicly available. This is the URL that you can check when it comes available. So conclusions, what this provides, shibboleth provides role-based authorization and access control to public access network, and it also provides increased privacy. And what it requires is a federation that's operational. We don't have yet operational shibboleth federation in Finland, and also the list of home institutions in that federation. And as a conclusion, this architecture could be a way to unify the network level and application level remote access to resources. Okay, any questions?
I have a remark and a question. The remark, you started with saying that you don't want to provide wireless LAN services for guest students from over the country. I would say that if you are able to provide adequate wireless LAN services for 50,000 students, you should be able to take care of those relatively few students that are coming into Helsinki and that want to open a laptop to do some basic things. That's one remark. We see that in the Netherlands, it's in any case not a problem. The University of Amsterdam, the Free University of Amsterdam, they see no problems with guest users.
Okay. Even in the city heart?
Yeah, no problem.
Okay.
Because they come there to go to the pub, not to use their laptop. That's one thing. The question is, you mentioned a couple of disadvantages of the web plus radius solution that the Finnish use. And I was wondering, I think a lot, apart from the role-based access, the combination of 802.1x plus radius would provide all these things. Wouldn't it be more logical to hook into that and use 802.1x, use the radius backend still to provide the where are you from service, and then on the backend hook into shibboleth, or provide a radius interface to shibboleth and make, in that way, all the access points would automatically be able to talk to that backend.
Interesting questions. Maybe these are the issues that are tackled in that GN2, GRA5, how to bring these two together. I wonder how to provide role-based authorization on radius without making proprietary hooks on the protocol.
It's the current way we use radius is basically not much more than to route some credentials. This, yeah, exactly what I said. Why not use the radius just for the wave? What you then over that radius infrastructure do is transport EAP messages. EAP messages are basic request response, how do you call it? Challenge response like operations, which you could send it through this hierarchy without a problem. It's invisible for the intermediate radius service, etc. So you provide the security on another level, and you can still send whatever information you feel like. But having said that, I don't want to sound negative. I think it's a very interesting idea, and I would really like to go over this a bit to see indeed how we can use this in GL2.
Okay.
It's really one of the two. Are there short questions? Because we have really called.
Short question, not for the speak, but for the moment. How do you do that? The question is, do you stop people or do you stop people to ship for
we have had integrated with your product for quite a while. We're actually talking
CRL in his entry. So if I click on that, you will now see this is the certificate entry. That's John Smith's certificate stored as a separate entry, and these attributes here have all been pulled out of fields from the certificate, apart from the object class, of course, because the object class is part of the LDAP schema. And you can see then that that's the actual certificate itself. So if you search on this entry and find a match, you can actually return the certificate from the entry that you match on. We've got here the version number, we've got the validity time, we've got the serial number, we've got the key information, we've got the issuer name, and we've got the algorithm identifier. If we go to this entry here, we've got a CRL, and it says who the issuer is. That's the CRL itself. In fact, this is an empty CRL, there's nothing in it. But if we go down here and we look at this one, we can say, click on this entry, we'll find that that CRL, and this is looking at the contents of the CRL, that CRL's actually got 3 revoked certificates in it. It's got certificate serial number 100 has been revoked there, and so that's the serial number of the revoked certificate. It's got another one with serial number 2 that's been revoked. Okay? So you get the idea. So now we're going to try and update this by deleting something. So if we go to this entry, then what we could do is we could delete a certificate from that entry, and of course that will delete the entry or entries below it. Now the one I'll delete actually is the certificate, and I don't know which one I'm picking, do I? Because there's 2 there. Let's just have a look at them and see which one I'm going to. That one is binary 874B, and that one is binary 585B. So if I go back to here, I'll delete 585B because I've got another one of that I can do. So what I'll do now is I'll go in Edit and delete attribute. Okay, selected value, delete. Okay, it's gone. Okay, if I then, this is a problem with the browser. The browser doesn't refresh the tree. You have to go in and you have to say view refresh. And when I refresh, it's refreshed the tree, and you'll now see that that certificate has gone. Okay, it's disappeared from it. So I can actually then go and put it back again. So I can do edit, add attribute, which is there. The attribute name is user certificate semicolon binary, and it's a binary certificate. So I want to insert from a file. So I now get a browser around. I can actually find a certificate, and these are various certificates. I don't know, they've all got different contents because we've tested certificates with different fields. So if I pick one of these at random, that one for example, open that and apply it, then it's been put in. So if I now do a refresh on this, you should see a new entry create below it. Refresh. There it is. And that's the new certificate that we've just added. So, amazing. It all worked. Okay.
Thank you there.
Okay. So, so if I go back the last 2 minutes, I've got the rest of the slides in the presentation. This stuff is all part of Internet PKX drafts, which Peter Geese wrote the first one, and then we've written the certificate, CRL one and attribute certificate one. We're currently in the process of updating them, and they will be posted to the PKX list within the next week or 2, because the plan is to, at the San Diego meeting, to get them into last call and published as Internet RFCs. And they're going to be published as Internet informational RFCs. So that's where we're at the moment. Okay. Any questions? Good. We finished on time.
Amazing. I think whenever a speaker is able to make a demo, give the explanation and wrap up everything in
15 minutes. Yeah.
Yeah, exactly. Read the form.
Yeah. Okay. Let's exit this file. Exit.
Okay, then thank you everybody for coming here, and I think you have still time to enjoy 5 minutes the sun and then to go back to the hotel. I guess I will see you at the reception.
It's amazing actually, it just all worked. And
Thank you very much for coming
yeah.
at very last
Right,
time.
okay.
Confirmed in like half an hour already. It's brilliant.
Anyway, I like your talk. So I want to add something about your talk into my PKI talk when I can. Is that, because I think I like what you've done actually.
Yeah. I mean, I can see the way. I understand what Serpnet said, because I do need to use the kind of application you have. For instance, if you have some government applications or some banking application, etc., then you want to have extra security. Of course, for students, you don't need it, because, I mean, to be honest, but also for us. Yeah, exactly. Also for us. I